Today we're going to solve inequalities with variables on both sides. Our essential question is, how is solving an inequality similar to solving an equation? So what is an inequality? An inequality is an equation that has a less than, greater than, less than or equal to, or greater than or equal to symbol instead of the equation or the equal sign. So instead of having something like x is equal to 3, we might have x is less than 3, x is greater than 3, x is less than or equal to 3, x is greater than or equal to 3. So this is very important when it comes to our solution because it means that we don't just have one number answer. If x is less than 3, it means x can be any number that's less than 3. So that could be 2, 1, 0, or it could be -5, -20, and so on. So there are multiple answers to an inequality. Or our x is greater than 3, it's anything greater than 3, so 4, 5, 6, on to 1 million. Looking at these two, the or equal to's, they're special because it includes the number that you see along with everything that is less than. So x is less than or equal to 3 means x can be 3 or everything else less than. Over here with our x is greater than or equal to 3, it can be 3 because or equal to, or everything else larger. So that's going to be very important when it comes to graphing our solutions. So let's think about what those look like on a number line. So it says draw a number line and plot. So I have n is less than 5. K is greater than 6. We're going to start with those two first. Now when graphing, there's two things to think about. We have an open circle and we have a closed circle. The open circle is used when graphing your less thans and your greater thans. The closed circle is used for graphing your or equal to's. Okay, because with an open circle, it lets you know that it's not including the number we're looking at. So n is less than 5, it can't be 5, it has to be less than. So I'm going to have an open circle to represent that. But when we go to these x's are less than or equal to 3, it can be 3, so we want to include it with that closed circle. So let's take a number line. Now this is just a little rough sketch, it's not perfect, and I'm not including every single number, I'm just including the solution. So if I want to graph n is less than 5, I will mark my 5 and have an open circle. It's kind of like a starting point, but it's letting me know I'm not actually including 5. Now I want to somehow graph everything that's less than 5. So I'm going to draw an arrow to the left, because this shows me that it can be any number that direction that's less than 5. Now let's try k is greater than 6. Again, it's not a perfect number line. This should also have an open circle because we're not including the 6, but k is greater than 6. That means it can be anything greater than 6. So I'm going to go to the right because those are all the numbers that are larger than 6. Now let's take x is less than or equal to 3. So I have my number line again. I have my 3. This time it's a closed circle because we are including the 3. It could be 3 or everything else less than. So if I want everything else less than, I want to go to the left. Our next one, x is greater than or equal to 3. I will have a closed circle because we are including the 3, but then I want everything else that's greater than, because x can be any number larger than 3 or be 3. So this seems pretty easy, but what about when our inequality is written backwards? So it says draw a number line and plot. Now these seem pretty simple, but this is the biggest mistake that I see. Students go ahead, they do their number line, they put the 4. I know it's going to be an open circle because I don't have that line. I see a less than symbol, done, I can move on. Well, let's look at that inequality and talk about it and then compare it to the number line. So this says 4 is less than x. That means x is actually greater than 4. So if 4 is less than x, x has to be more than 4. Well, look at what we graphed. We graphed less than 4. Well, that's not our solution because x could be anything like 5 or 6 or 7, and that's not included on our graph. So one way to avoid that mistake is to rewrite your inequality. So instead of thinking this as 4 is less than x, we're going to think of it as x is greater than 4. So I can graph this on my number line. It will be an open circle, and I want everything greater than 4. 3 is greater than z, which means z is less than 3. So that's how I'm going to write it. This will be an open circle because we are not including the 3. Z is less than 3. Draw it to the left. Right, our next one, we have 2 is less than or equal to b. So we're going to think of this as b is greater than or equal to 2. I'm going to go ahead and rewrite this other inequality. X is greater than or equal to c, which means c is greater than, less than or equal to 8. Now this time, because b is greater than or equal to 2, I can include the 2 and everything else greater than. And then on my next one, c is less than or equal to 8. I can include the 8 and everything else less than. So hopefully that's been cleared up. Now let's actually solve some inequalities. So how is solving an inequality similar to solving? Solving an inequality is very similar to solving an equation. So we're going to follow those same steps that we did yesterday. It says you can solve an inequality with variables on both sides, much like you solve an equation. Now this piece can get a little tricky. It says, but remember, when you multiply or divide both sides of an inequality by a negative number, you have to flip your inequality symbol. Now this may sound a little confusing, and I'll show you an example of when that happens, but if you're following the steps that we use to solve equations by getting rid of your smallest variable first, you never have to worry about this step. And then finally, be sure you are correct. To be sure you are correct, you can check your test. You can test your values through substitution. So how many different numbers could be the solution to an inequality? We'll figure that out. We have to first solve the inequality. So if I'm looking at this, positive 3x plus 7 is greater than 5x minus 6. My variables are both positive, so I'm going to look at the 3x as my smallest. Get rid of it by subtracting. Do that on both sides. My 3x's cancel. I'm left with 7 is greater than. Make sure you're bringing down your symbol and not writing that equal sign. 5x minus 3x. I'm left with 2x's. Bring down your minus 6. I have my variables on one side, so I need to get my non-variables on the other. I'm going to add 6 to get rid of the minus 6. Do that to both sides. Combine this, I get 13 is greater than 2x. My 6's cancel. I still need to get rid of that coefficient of 2, so I need to divide both sides by 2. 13 divided by 2 will give you 6.5, so we can think of that as 6 5/10 is greater than, my 2's cancel, x. So our solution is 6.5 is greater than x, or x is less than 6.5. So that means if I pick any number that is less than 6.5, it should give me a true statement when I substitute it into my inequality. So let's try that. So let's think of a number that is less than, because x is less than 6.5. Let's think of a number that's less than 6.5. I'm just going to pick 5. So I'm going to substitute in x equals 5, and we're going to see how that works out for us. So, and I didn't pick 5 for any other reason except that it's less than 6.5. I could have picked 3 or 1. I don't want to pick 0 because we could pick 0, but let's make it a little bit more challenging. So I'm going to go substitute in 3 times, instead of x, I'm going to put a 5, plus 7 is greater than 5. Let me fix my greater than symbol so we don't confuse that with my 7. 5 times 5 minus 6. So I get 15 plus 7. Bring down my greater than. 25 minus 6. 22 is greater than, and when I do my 25 minus 6, I get 19, and 22 is greater than 19. So that worked for our solution, and we could check multiple numbers that are less than 6.5. But if it works, we know that our solution is correct. We know that x is less than 6.5. So let's try another example. Solve each inequality, test your answer, graph your answer on a number line. These are all the steps that you're going to have to be able to do on the assignment. So again, I have positive 2x minus 5 is less than positive 3x plus 6. My smallest variable is the positive 2x. So to get rid of positive 2x, I'm going to subtract 2x from both sides. My 2x's cancel. I'm left with negative 5 is less than. If I have 3x's and I subtract 2, I'm left with just 1x. Bring down my plus 6. I need to get rid of this plus 6 by doing minus 6, minus 6. These cancel. I'm going to bring down my x. I'm going to bring down my less than symbol. Now, this is the step that I saw a lot of mistakes of during the scavenger hunt, so make sure we're using that calculator to test our solutions. A negative 5 minus 6 more will give you a negative 11. So our solution is negative 11 is less than x, but remember we want to think of that as x is greater than negative 11. Notice in both of these, the symbol is opening up to the x, so that's another way you can check to make sure you flipped it properly. But again, we want to test this and then graph it. I say test first because you're going to go through all of the trouble of graphing and then you test, and if you get the wrong answer, you have to go back, erase, and then regraph. So let's test first. So if x is greater than negative 11, let's just pick any number that's greater than negative 11. You don't have to pick a negative number. I'm going to pick an easy number. I'm going to pick 2 because 2 is greater than negative 11. So I'm going to substitute in 2 times 2 minus 5 should be less than 3 times 2 plus 6. And again, I chose 2 just because 2 is less than, 2 is greater than negative 11. So that gives me 4 minus 5 should be less than 6 plus 6. 4 minus 5 is a negative 1 is less than 12. And negative 1 is less than 12, so it worked. So we know our solution is correct, so let's go ahead and graph. Again, I have that. This is our solution. Over here, this is what we tested, so I'm not going to graph the 2, I'm going to graph my actual solution. So I have negative 11, and then it should be an open circle because I don't have that or equal to. And then x is greater than negative 11, so it needs to go to all numbers greater than. So we solved it, we checked it, and we graphed it.